Now, before we begin to find the inverse function, I want you to first look at the function and figure out the domain. Okay? What's the domain of this function? Well, can you plug in negatives into exponent? Yes, you can. Okay, because like, what's like negative 10th power? That's like 1 over 2 to the 10th power. That's fine. You can plug in negatives. You can plug in positives. Nothing stops you from plugging any real number into the exponent. So the domain is all reals. Now, when we get to the next type of questions, when the question is given as a function of a log, that's a different story. Logarithmic functions cannot accept 0 or negative. You can only accept positive. So there you have to be careful. But if you don't see any logs, if you don't see any square roots, if you don't see any denominators with x in there, then nothing stops you from plugging in anything that you want. So the answer to this is that x can be all reals. Now, why do I want to know this? Well, you'll see in a second. Okay? It will be a very valuable piece of information later. Right? But our immediate goal is really to find the inverse function. Can you tell me how to find the inverse function? Yeah. You swap x and y. That's the most important idea, right? You have to swap x and y. However, I tried to say something one before, because here you don't see a y. What do? You make f of x as y. And so if you want to swap x and y has to be there. If you don't see a y, then you replace f of x as y. So that's the first step. Rewrite so that instead of f of x, you put y in there. And now you can swap x and y. So y is replaced by x, whereas x is replaced by y. Okay. But now what? What do? You isolate y, right? You're solving for y. Okay, so so the big two ideas in finding the inverse function is swap x and y and solve for y. That's how you solve inverse functions. Okay. So we're trying to solve for y, and it looks like 5 is the easiest one to move, because all you have to do is add 5 both sides. So let's do that. Add 5 both sides. That gives you x plus 5 equals to 3 times 2 to the y. Now what should you do? You can divide the 3 out, right? 3 is multiplied to this thing, so you can divide by 3. So you divide both sides by 3. This is the end result because 3 got canceled away. Now, how do you get rid of this 2? This is the last thing remaining. Then if you get rid of 2, then you have y isolated, right? How do you get rid of 2? What do you do? Yes? Log of 2. You apply log of 2. You use the cancellation property, right? Log of 2 to the y, and these two cancel. And therefore, you get y equals to, well, you should write it f inverse. So your answer should be in this form. F inverse of x is equal to log base 2 of x plus 5 over 3. Okay? So that's the inverse function. We obtained the inverse function. Now, one thing I said over and over again, so by now you're kind of tired of me saying this, but I constantly talk about boots and socks, right? Yeah. In the morning, you put your socks on and then boots, right? When you come back home at night, which order? Boots come up first and then socks, right? Which means when you try to solve for something, when you try to undo something, then you want to do it in the reverse order of something that's applied. So look at this y. 2 is closest to y, right? And then to this, you're multiplied by 3 because of PEMDAS, right? Multiplication is before subtraction, right? and then you're subtracting 5. So now when you try to solve for y, you have to do it in reverse order. That's why we're making 5 go away first, and then make 3 go away next, and then 2 is gotten rid of the last, because that's the first thing that's applied to y. Okay, so you should always be aware of this, because it does become quite confusing if you have more stuff in the thing and you have to solve for y, right? Okay, so we're almost done. We still have to figure out the domain and range. Okay, so let's look at the domain of this. Can you plug in -1 into this function? Is that okay? -1 plus 5 is positive 4, 4 over 3. That's a positive number. As long as you have a positive number inside the log, it's fine. Yeah, it's perfectly fine. Okay. Now, can you give me a number that would be illegal to be plugged in here? What value of x would be illegal? Give me a number. -6, right? If it's -6, -6 plus 5 gives you -1, and -1 over 3, that's a negative number that can't be evaluated in the log. That would be illegal. So -6 is no good. Anything below -6 won't be good either. How about -5? Would that be okay? Well, -5 plus 5 is 0. Is log defined for zeros? No, that's the difference between the square root. Square root, you can evaluate square root of 0. That's fine. Whereas log of 0 is not allowed. So that means -5 is also not okay. However, once you go just tiny amount beyond -5, it's fine. It's like -4.99. That's fine. You can plug that in and it will calculate. All right. So what's the domain then? Domain is from -5 to infinity, not including -5 itself. So that just means it's not including -5, but you just need it to be just slightly bigger than -5. That's what it means. Okay, so that's your domain. Now, if what I just said is confusing, here's a more streamlined version. What you're going to do is you're just going to take whatever that's inside the log and write down what's needed. Anything inside the log must be bigger than 0. It has to be always positive. Okay, so you say it's bigger than 0, and now you just have to solve this inequality. How do you solve it? You multiply both sides by 5, but you multiply both sides by 3. 3 times 0 is 0, so this is what you get, and now you solve by subtracting 5 both sides. So you get this. On the number line, what it means is that x is on the right side of -5, but not including -5. So if you drew this on the number line, it would be like this, with an open circle here, right? So in terms of the interval notation, how do you represent this? It's from -5 goes up till infinity, not including -5 itself. So it's like this. Okay? If -5 was included, then you would be using rectangular bracket, but since -5 itself is not included, you use this parenthesis. In fact, when it comes to finding domains and ranges of exponential functions and logarithms, you will never encounter a bracket if it's these simple ones. I mean, I guess you can kind of work hard to make something like that work if you have like x squared inside the log or something. Sometimes that could happen, but in this class, you'll never encounter a bracket when you write down domain and range, okay? All right. Now, what about the range? What will be the range? And this is why I was talking about this. Okay? Because the function and the inverse function has a relationship that you're switching x and y, right? Input and output is switched, right? So what was the domain here will become what? The range here. So the range will be automatically -infinity to infinity, just because the domain of the original function was -infinity to infinity. Did you get what I said? Let's see if you understood. What's the range of the original function then? -5 to infinity. So the range of this function is this. And in fact, you could have even figured this out by drawing the graph. We learned how to draw the graph of the exponential function, right? So you could have drawn the graph of this exponential function by simply saying, well, y equals to 2 to the x is like this, with this being 1, right? And then you're multiplying it by 3, so it becomes bigger, right? But then you're subtracting 5, so you're moving this down over here. So this will be the graph. Originally, the exponential function has the x-axis as its horizontal asymptote. That horizontal asymptote gets moved down by 5 because you're subtracting 5. So this new horizontal asymptote will be at -5, and the graph goes like that. And therefore, from this graph, you see that the range is above -5. It never goes below -5. So that's how you can find the range of this. And if you know these, you can just switch these around and get these one without having to solve the inequality. So that's another way to do it. But drawing graphs is not so easy. So I think it's better to just solve the inequality, right? Okay. Again, I want to start out by noting the domain. What's the domain of this function? What's the domain of this function? Negative infinity to infinity, yes. Because there's nothing stopping you from plugging a negative into the exponent. That's perfectly fine, okay? So that's what you have. And then let's just proceed to introduce the y. Switch x and y. So what I did was, instead of y, I put an x. Instead of x, I put a y. Now I have to solve. Which one should go first? 7. Okay. See, look at how close something is to y. 2 is the closest, and then 3 is closer than 7 because of PEMDAS. 3 has to be multiplied before plus 7, right? So 3 is the next, and then 7 is the last. So the last one should go away first. We're going to subtract both sides by 7. Okay. Next, I have to get rid of -3. How do I do that? Divide by -3. Which gives you that 2 to the y is equal to x minus 7 over -3. Now, if you like simplifying stuff, I think slightly better way to write this is to write it as, put a negative. See, you can multiply -1 top and bottom so that the bottom's positive and the top is negative. You can bring the negative upstairs. Okay. If you do that, then this can be written as set positive 7 minus x over 3. I think this is slightly simpler, but it's up to you. If you're not so sure if you can do the algebra, just keep it as x minus 7 over -3. That's fine. Okay. But anyways, so this is recommended. If you're not sure, this is fine. Okay. All right, now you have to get rid of 2. How do you do that? Log base 2, right? Log base 2 of 2 to the y equals to log base 2. You have to take log base to both sides. These cancel, and now you have f inverse of x equal to log base 2 of x minus 7 over -3. Okay. Now, if you did manage to convert to this one, then finding the domain is slightly easier. This does create some problems when you try to find the domain. But nonetheless, let's try to find the domain of this function. To find the domain, what do? You take the entire thing in the log and set it as greater than 0, right? Okay. You set it greater than 0, you multiply by -3 both sides. And these cancel, you get 0, so x minus 7 is greater than 0, so x is bigger than 7. Okay, I just made a mistake. What's the mistake I just made? Can you figure out? The answer is wrong. This answer is wrong. Why is it wrong? Yes. Yes, when you multiply a negative in an inequality, what do you have to do? Inequality direction must change. You have to switch the inequality. So the correct answer is what? Less than 7, okay? So that means the domain of the inverse function would be negative infinity up to 7, right? Not including 7, it has to be less than 7. What will be the range? Negative infinity to infinity. How do you know that? Because that was the domain of the original function. Domain of the original function will be the range of the inverse. Okay? All right. So how is it so far? Tough? Easy? Easy? Okay, good. Okay, let's try out this one. This time, some slight changes. This minus 4 is not down here. It's in here. Okay? So it's actually closest to x this time. Okay? We'll think about what that means. But first, what's the domain? Negative infinity to infinity. I don't see a log. I don't see a square root. I don't see a fraction. I do see a fraction, but x is not in the denominator, so that's fine. Okay? So that means domain is all reals. There's nothing stopping you from plugging in negative or positive or anything. Okay, now you introduce the y, switch x and y, so x is equal to negative 1/2 times 3 to the y minus 4. And you're trying to solve for y, right? And this time, because y minus 4 has to be done first and then raised over 3, this should be done last. Okay, yeah. All right, you get that? Okay. And then let's look at the order. This is closest to y, and then 3, and then you're multiplied by negative 1/2. So which one goes away first? Negative 1/2 has to go away first. How do you get rid of negative 1/2? Okay, so one way is to divide by negative 1/2, but I don't like this. I don't recommend this because you have multiple fractions, right? Because then you have to do keep, change, flip. Some of you are not so sure of this process. So instead of dividing by negative 1/2, we're going to multiply by the reciprocal of negative 1/2, which is negative 2. You multiply by negative 2 both sides. And then it's going to cancel this negative 1/2. If you multiply a number by its reciprocal, you get a 1. Right? So it cancels away. So you get negative 2x equal to 3 to the y minus 4. Okay. Now what should go away? 3 has to go away, right? So 3 has to go away. How do you get rid of 3? Log base 3. So you apply log base 3 both sides, which is going to cancel the 3. And then you get log base 3 of negative 2x equals to y minus 4. Now, at this moment, some of you might get nervous because you see a minus inside the log, and you're just told that you can't have negative inside the log. But this is fine. Why? Because all it's saying is that x has to be negative. As long as x is negative, negative times negative is positive, so there's no problem with it. Okay? You get my point? So don't be deceived by this negative sign. It really means that x has to be negative. If x is negative, negative times negative is positive, so it's fine. Right? Okay, so this is all good. Now you're almost there. How do you solve for y now? add 4 both sides, right? Then you get y equals to this plus this, which means f inverse of x is now log of 3 of negative 2x plus 4. All right. What's the domain? How do you find the domain? Take whatever that's inside the log. What do? You say it's greater than 0, always. Okay, whatever is inside the log, just say that's greater than 0. That's how you find the domain. Okay, and then you divide by negative 2. What do you have to do if you divide by negative 2? Switch the sign, 0 over negative 2. But that's 0 divided by negative 2 is 0, right? So x just has to be less than 0. But we already knew that. The only way this could be valid is if x is negative, right? So that is the domain. How do you write that in interval notation? Domain is negative infinity to 0. Never square brackets in these questions for logs and exponentials. The domain and range never has square brackets, so this is fine. And then now what? Now what's the range? It's the domain of the original functions, negative infinity to infinity. Yeah. Okay. As usual, we will start out by thinking about the domain of this function because finding domain is easier than finding range. To find the range, you have to know the graph, so it's harder. So if you can find the domain of this, it's going to be the range of the inverse function. So it makes sense to find the domain whenever you have these kind of questions. Okay. So how do you find the domain? Well, this time I do see a log, right? So how do you find the domain? Take anything that's inside the log, and what do you say? Bigger, no, can't be equal, strictly greater than 0. Okay. And now you add 3 both sides. Therefore, the domain is 3 to infinity. Yeah. Okay. So that's the domain. All right. Now let's proceed to change x and y, swap x and y, and then solve for y. So instead of y, you put x. Instead of x, you put y. Again, boots and socks, guys. You have to know which one comes closest to y and undo the ones that's outside, okay? Yeah. So minus 3 is closest to y, and then you have log, and then you have multiplication, and then you have plus 1. So 1, yeah, you're right. 1 has to go away first. You subtract 1 both sides. Okay, now what goes away for next? 2. 1/2, yeah. How do you get rid of 1/2? Multiply both sides by the reciprocal, which is 2. Don't divide by 1/2. That just makes it harder. It's easier to multiply by the reciprocal. So we multiply both sides by 2. They cancel away. Now you have to get rid of log base 4. How do you do that? Take the power over 4, right? So you get 4 to the log base 4 of y minus 3. They cancel. And now you have y minus 3 equals to 4 to 2 times x minus 1. Okay? Finally, what do? Add 3 both sides. So f inverse of x is now 4 to the, you can multiply this out, so you get 2x minus 2, and then plus 3. That's the inverse function. What's the domain of this function? What's the domain of this function? Huh? From where to where? It should be an interval. Negative infinity to positive infinity, yes. Okay, what's the range of this function? 3 to infinity, because that's the domain of the original function, right? Okay? Actually, I'll need to write this as 2 minus 3x. Okay, let's think about this example. Before I try to find the inverse, let's look for the domain. What do? We take 2 minus 3x and say that's greater than 0, okay? Now, it's easier if you add 3x both sides, because then you don't have to divide by negative. It's less confusing. So 2 is greater than 3x, and then you divide both sides by 3, and that gives you that x is less than 2/3, right? What is this interval notation? It's left of 2/3, so where do you begin? Negative infinity until 2/3. Okay, so that's your domain. All right, now let's do that thing. Introduce y and swap x and y. So instead of y, I put x. Instead of x, I put y. Now we have to solve for y. Again, pay attention to which is closest to y. So 3 is closest to y, and then you have to subtract from 2, and then there's a log, and there's a minus, right? So the one that's done last should go away. Which one should go away first? Minus, right? How do you get rid of the minus? You multiply both sides by -1, or you just flip the sign, right? So you can say that ln of 2 minus 3y is equal to -x. Now, another way that I'm thinking is I'm just bringing this over here, bring that over this other side. Then if you cross the equal sign, the sign changes, right? So when you move this over here, it becomes plus. When you move it to the other side, it becomes negative. Okay. All right. What should go away next? The natural log. How do you get rid of the natural log? You raise it over e. Yeah, because what is ln? Ln of x means log base e of x, right? So because ln is a shorthand for log base e, if you raise it over e, then these cancel to give you x, right? So e and ln cancels. That's why you have to remember. Okay. So that's what we'll do. We're going to put both sides over e so that these two cancel, and you get 2 minus 3y equals to e to the negative x. Okay. Now what should we get rid of? 2. Subtract 2, and you get negative 3y equals to e to the negative x minus 2. And finally, divide by -3. So you have y equals to e to the negative x minus 2 over -3. But, you know, it's not good to have negatives in the denominator. You should kind of feel uneasy about that. Okay, so in such a case, try to multiply -1 top and bottom so that you have f inverse of x to be -2 times -1 is positive 2, and then -1 times e to the negative x is negative e to the negative x. -1 times -3 is positive 3. So that's a better answer. Okay. All right. What's the domain of this function? What's the domain? Very good. Now you really know. Range would be -infinity to 2/3. Okay, good.